Assalamualaikum and good evening to all my beloved panel, which is Dr. Azrul, Cik Masan and Dr. Lokman. So my name is Mohd and today I will present about my final year project PSM2, which is automated road sign recognition, which is supervised by Dr. Faidzil, bmfg. So first of all, I have to advise from Dr. Azrul, which is to make my video become a little bit smaller. So I have made it become a bit smaller. Okay, first we proceed to my problem statement, which is in Malaysia there are many people in Malaysia, motorcycle or wheelban, and that cause many traffic accidents nowadays. So many off-road drivers did not see, or sometimes they are overlooked over the road signs surrounding them. So many road signs or symbols give people alert and hazard about their surrounding, but sometimes they ignore it, and then they drive very dangerously. Okay. So for my first objective is to identify technology and method used to solve the problem. For the second objective is to develop road sign recognition system based on neural network to detect road sign, and the third one is to investigate common use of the proper system in recognizing road image sign. So for my scope is I want to show that to identify and show the detection and recognition of the road sign, and run road sign system in Python to show it can recognize NPC and detect it. So we move to the next, which is methodology. So this is my overall project for PSM1 and PSM2. So for PSM1, I have achieved my first objective, which is methodology development of road sign. So for the first objective, I want to study to investigate the methodology or technology used to develop road sign. And then for PSM2, I have also achieved my second objective, which is develop code programming in Python, which I use based on the neural network, which is CNN, to develop the coding to make it more faster code detection. Sometimes coding also affect our time taken to detect and recognize the image. So in PSM2 also, I have achieved my objective 3, which is I run Python detection and achieve and give accuracy. So for the objective 3, I have shown that my performance, is it good or not. So in this case, I have achieved my objective 3 and to show that performance of my detection. Okay. Second methodology is, for the hardware I used to make this project is my personal computer, which Intel Core 3.7 GHz something that's a little bit, maybe it's a little bit laggy for this day because I bought it on 2018, something like that. And for this I have upgraded to 8GB RAM, so it will give more boost to run the training in this computer, I think. For the image I capture with my phone, which is iPhone 11, which will give a good resolution and image, which is make it clear and easy for the CNN or you to recognize it when you're training. So the software I use in this project, which is the Python, OpenCV, NumPy, Double Image, and Google Colab. Then cascade classifier was used to identify object in an image and video. This is OpenCV software provide cascade classifier, so we do not have to worry about to install or another software to support to make the image. Since cascade classifier only can produce high detection accuracy and give more lower false and positive rates when training and recognizing image. So cascade classifier will train positive and negative image, and we can conclude on the final result which is the best accuracy or not. So in this experiment, in this project, I have prepared the target data set, which is 5 types of road sign to collect to be a main data, which is sign for stop, bump ahead, children cross, speed limit, and no entry. Then in this method, I will use the YOLO V3. YOLO V3 is 17 times faster than its rival faster RCMM. Since YOLO has a 3 version 1, version 2, version 3, and RCMM like that. But in this case, I will use YOLO V3 because it's a very latest update, and it shows that it give high accuracy compared than others. So I choose YOLO to support with convolutional neural network to give more high accuracy and give a better recognition on the image to label it. So in YOLO V3 architecture, it provides a .NET 53, which is a new one for this year, that able to process image with at different partial compression. So when you can see this image, that YOLO V3 show how it works when it's training image or if it's an image. So the expression for YOLO V3 I use in this project is max_batch, which is setting it on the YOLO V3 train.csv file, which now you can change their parameter. So number of classes with time by 2000, that is the formula. So number of classes, it depends on our time. So in this experiment I use 5 times, so number of classes will be 5 type of number classes. So 5 will time by 2000 and we get 10,000. So that means the max batch for the epoch. And then filters. So filter we need to change its parameters. So parameter filters will be number of classes plus 5 and multiply by 3. So number of classes in this experiment will be 5. So 5 times 5 will be 10, and times by 3 will get 30 filters will be used in this experiment. So convolutional network. So this is the base nowadays for computer algorithm to detect. So convolutional network is can take an image time process to extract object in the image. Okay, so the amount of processing required in the convolutional network is significantly less. It means that it does not have any much layer compared to other neural networks like ANN, RNN, and many more like Keras or TensorFlow like that. So convolutional network use less layers. So in this situation it shows that it uses only 4 layers to detect an image. So in this layer it concludes with a pooling layer. Pooling layer is something that will reduce number of parameters in input. So max pooling and average pooling, there are 2 types in the pooling layer. Max pooling can be used to reduce the volume of faidzil, and average pooling is a non-suppression strategy, which it can reduce noise suppression when we at the rain condition or night. Sometimes there are noise in the image, so you can reduce it and make it detect more better. Okay, and then in the layer of the convolutional network, there are fully calculated layer, which is reflect the image into column vector after it's been transformed, and able to receive negative high level and low level each image throughout the period of epoch. So we can see the image here. Okay, and then result and discussion. So in this experiment setup, I have 4 variables that I have shown in the experiment, which is detection based on the reason, constant angle, during weather condition, and driving. So for the various distance, you can see that there are 1 meter and 3 meters. So the angle we took it from 0 until 20. So the location is set in Taman Tasik Taman Aiko, because there is a very less heavy traffic right there, and it's safety for me to take picture around it and training. So the condition for the very distance will be at daytime and night time. So we can see, is it my project only can be take during day or night. Okay, and then the time taken for the day is 2:50 and the night at 10 p.m. So for the constant angle also, it also same with various distance, but I even change in a distance, which I use for 1 meter only, because I want to detect for the constant angle. It can take at the angle of 45 degrees. So the location also is the same, and the condition also I will carry out during the daytime and night time. So during detection, during the rain condition, I should it with a 2 meter or 3 meter distance within angle or between 0 or 60 degrees. Okay, this rain condition only set up during a daytime. So because in Melaka at night there was a heavy rain, so I cannot go outside, because it's very dangerous and my body is still wet, so I only took for a daytime. So at that time they are medium rain, so I must check it very fastly. So the time they take is at around 10 AM. And then detection during a driving. So during driving, I will sit in the car and try to detect image, which is distance is around 5 meters or 7 meters, and the angle will be around 10 or 50 degree angle, which is on the left lane. Okay. Many times that I took image on the left lane. So the location also is very the same at Taman Tasik Taman Aiko. And the condition for this experiment setup will be daytime and night time. So whether it detect only day or night. So for the time on the day is around 4 p.m. and at night is 8 p.m. Okay, then we proceed for the detection and reflection based on various distance day. Okay, during day, okay, this is image for 1 meter and 3 meter. So we can see that the accuracy that it detects for 1 meter and 3 meter. Okay, sometimes it shows that 1 meter will detect a high accuracy better than compared to the 3 meter. But okay, for the table that we get score, you can see that for the 1 meter it gets low, maybe something low than 3 meter. Okay, for the lowest accuracy in this experiment is a sign with no entry is dalam masuk, only obtain 0.50%. Okay, this is because of the information since Google Collect provides since the training for total of 5 types of visual sign is 72 hours, but my Google Collect only provide only 60 hours free. So in order I want to get a lifetime training of image, I need to subscribe for Google Pro, which is around $45 per month. So that is too expensive for me and I cannot afford it. So I use only resource that I have since I am only a student and university do not provide anything for me. But I did try my best to get a training for this image. So for this training, I have overcome it to show that my detection also can improve the image that got a lowest accuracy. So, okay, this is the training result for 1 meter distance. Okay, this is the result for the I have retrained for 1 meter since sign of berhenti and bonggol get around or 71 or 75%. So I have to improve it to show that my detection is good. So after I retrain it in Google Lab, it consists of 15 hours to train because there are only 2 class of road sign. So the 2 class will insert in the formula and we get around 15 hours of training, something like that. And then after it complete the training, okay, I have achieved a better result, which is for berhenti is 0.99 and bonggol is 0.98. So that means it increased from 20%. This is a very good result. So we can see that it compared to the 3 meter, it for 1 meter its score has increased 20% and make it better than 3 meter. But I did not retrain for the no entry time which is dalam masuk because my SB is need to focus on bonggol and berhenti to improve and retraining the image. So I listen to him and take his advice to retrain it to show that this experiment is successfully carried out and it also can improve my accuracy. Okay, and then this is result during the night. You can see for 1 meter and 3 meter. Okay, in this situation, seems like 1 meter and 3 meter got a higher accuracy, but we can see that 3 meter score for berhenti and bonggol is 1 with 100%, which is very very accurate. But berhenti and bonggol darapan is 0.98 and 0.86, which means that for a logical theory that 1 meter will get a more accuracy better than 3 meter because they have different distance. So in this case, for the Google Collect Pro, if we achieve the 72 hours of training and get the total of 10,000 people, so overall of this road sign will get a high accuracy, which is 95% and above. But since my Google Collect is not a lifetime training and it's not subscribed and it's a free package for students, so I cannot achieve the accuracy. But we know that how to encounter it, since it needs a complete training to achieve the highest score for detection. Okay, so for this distance for at night, we can see that lowest score in this case is Halaju. Since Halaju did not complete the number of training, since we can complete this number of training with lab, which is 72 hours. it will also get a high better chance of accuracy, which is mean that 90% and above. It's like we're training for the bongo and the bongo and the masuk, it also achieves it increase for 20% accuracy. Okay, and then for the constant angle, this is the result for a day and a night. For the constant angle, it is a 45 degrees to show whether it can act on constant angle or not. So here are the results for the day and night. You can see that the lowest score for this result is the high laju. This is because high laju get a less result. There are lack of training image for this method. Okay, in order to improve it, we can training the image of within the complete hour of training, which is 72. Or if we want to be training the image for the one picture, so it maybe take a less duration for the image to training. Maybe some like 10 hours or 15 hours for the one type of image, one type of class. Okay, and then it can be more improve of their accuracy correlation, and it will also achieve 90% and above. Okay, and then for based on the rain condition, you can see that in a day. So for the during a day, I only can look for classes since when I training the image and took the image on the question. It was a very heavy rain, so I cannot proceed with my experiment, and I have looked for image for result for the rain condition, and I have approached to my supervisor, and my supervisor, okay, you can proceed because there is heavy rain. So this is the score during a rain condition, which is we get a high accuracy. For bomba harapan 90%, hal laju 91%, darah masuk 96%, and kanak-kanak besar is 90%. So for me, that this detection is very good for using a CNN with combine of YOLO. Even in a rain condition also, it can detect the image with a better chance. Okay, and then the last result is during driving on the road. So during drive on the road, there are two conditions, which is day and night. So the distance setup, I'm not assume, because I assume only to take a long distance, which is around 5 or 7 meters, something between. So in this case, for the day, I only have took 3 class only, because of also during since measure is on the rain condition something, so it's a very heavy rain. I cannot took the image even inside the car because the image is so mirror with the water on the mirror. So this I have also approached to my supervisor, and he also said to continue and carry on because there are any situation, because there are unexpected situation to occur during a rain. So it's a very dangerous for me to proceed and take image only during the day. So this the image during the day and the night. So we see that hal laju for the day consists only 0.6 accuracy. This is a very low score for this result. Since hal laju from this, you can see that it is obstruct object is big on the road sign. So in this case, we must be training the image in order to achieve a better accuracy. Since like I explained that later, since I explained that before. Okay, in order to achieve a high accuracy, we need to retrain it, or we do the experiment carried out on the total 5 class of image, and we must complete the time taken to train it. Since my experiment for all these 5 types of time consists of 72 hours, and I only achieve for 50 hours free because Google Collect only provide 50 hours, and I need to subscribe or purchase it. So in other ways to counter it, we can retrain the image to get a better high accuracy. So instead of 0.6, we can achieve more above than 90% and above. So it will give a better result to detect an image. So we can see that any any various condition, this image can still detect and recognize it with a correct label and also achieve a high accuracy score. So that means that Gaussian N and YOLO is a good method to use for detection and recognition for anything method, unless like a face recognition, hand gesture, or other method to detect. So I suggest to use the SNN and YOLO in order to do another project which is detection and recognition. So the overall system for performance evaluation, okay, this is the formula to calculate the error and accuracy and also a mean of the rate. So in this case, in Google Colab, it has automated calculated to produce the accuracy. So this is the example of my Google Colab training. So in this, that shows all the number of call positive, total number of entry positive. So it's automatically calculated and gives you the result. So Google Colab will make us easy to use because it's provide all anything. So we just have to use Google Colab in order to get a easy way or something else if you want not any to find it on a harder way. So Google Colab is very good because I did not have to calculate it manually since Google Colab has calculated all it automatic, so I just put into all my results. Okay, and then for the errors in image recognition and detection. So for this error in my project, the train data not consumed image. This is example of train data that do not consume image. Since we did not training any image, so this detection animation cannot detect and cannot read because they have no training. So if we run on the CMD, it will give this result, which is a non-type of object as not attributed to copy, which means that if there is no data set on the coding, so they cannot recognize and detect. And then the second one is positioning label we animate. So positioning label we animate is very important. Since if we label with a wrong side, with a wrong position, it will not give any detection. It will not show the label and its accuracy. So label is for positioning and we give the error by 1 or 5 code. Show an error occur during detection will occur negative result. So in CMD, it will give a negative result because it cannot detect because the label is not positioning on the correct way. So the conclusion is I have achieved my objective, which is use YOLO BPM convolutional network method to construct automated road translation and achieve my objective 1. Second one, I have successfully developed road time using neural network system to achieve my objective 2. And for the last one of my objective is detection accuracy increased by 25 or 50% after the image and achieve objective 3, which is to evaluate my performance, which is better or worse for this experiment. So I have achieved that this method, this performance is very good and achieve a higher score, which is a 90% above. In order to gain the lower score, we need to retrain the image, the first method, or we need to subscribe on the Google Colab Pro, which is must pay around $45 per month. So that's it for me. My name is mohd, and this is my explanation of what I have done for my PSN, which is automated road time recognition. Thank you to all my panel.